Every logarithmic equation is the inverse of an exponential equation. So if the log base b of n equals a, we know that b raised to the a power equals n. For example, if the log base 4 of 64 is 3, we know that 4 to the third power is 64. A common logarithmic equation has a specific base of 10. So if the log base 10 of n equals a, then 10 to the a power equals n. If we write log n equals a, the implied base is a 10. A natural logarithmic equation has a base of e. So if the log base e of n equals a, then e raised to the a power equals n. E is approximately equal to 2.718. Another way to write log base e is ln. So writing ln of n equals a is the same as writing log base e of n equals a. Now let's find the value of the log expression log of 100. We don't know what that value is, so we'll call it x. And it's going to be helpful to remember that a log is a log with a base of 10. Now let's rewrite this as an exponential equation. 10 raised to the x power equals 100. We'll rewrite the 100 as 10 to the second power so that we have equal bases on both sides. And since the bases are equal, we know that the exponents have to be equal. So x equals 2, which tells us that the log of 100 equals 2. Here's another example. Let's find the log of 1/10. We don't know what it is, so we'll call it x. If we remember that log means log base 10, we can then rewrite our log equation as an exponential equation. 10 raised to the x power equals 1/10. Now let's rewrite the 1/10 as 10 to the negative first power, so that we have a base of 10 on both sides of the equal sign. If 10 to the x equals 10 to the negative first, we know that x has to be negative 1. So the log of 1/10 is negative 1. Now let's evaluate a natural log expression. We don't know what the natural log of e squared is, so we'll just call it x. And then we'll remember that the natural log is the same thing as a log with a base of e. Now let's rewrite our log equation as an exponential equation. E to the x equals e squared. And since our bases are the same, our exponents have to be equal. So x equals 2. So we know that the natural log of e squared equals 2. When we're working with logarithms, it's sometimes useful to remember the properties of logarithms, which apply for logs with any base. If our base is 10 and we have a common logarithm, we still have the same properties. But wherever we saw a b in those properties, we now know that the base b is equal to 10. So our properties look like this. And for natural logarithms with a base of e, we can rewrite the properties looking like this. Anywhere where we saw a log base b, we now see an ln, and we know that the base of b is equal to e. Now let's go back to this problem that we worked before and see how we can find the same value of the natural log of e squared using the properties of logarithms. This is the property we're going to use because we do have a natural log of e to a power. The property says that we can bring that power out front and multiply it times the natural log of e. And since the natural log of e is 1, we now have 2 times 1, which is 2. And that's exactly the same answer we got the first time we did the problem.